First of all, let's differentiate between cables and connectors. Cables, well, here's a cable. Here's a picture of a cable. You can see there's no ends on it because that's the connectors. So the cable really is the path for the electrical signal. It's the path for the electrical signal to get from point A to point B, whether it's from a device over to another device, from a microphone to the speaker, from a microphone into a camera, from your iPhone connected to a computer, whatever. It is the path. And it's the connectors that are the device for joining the cable to the device, or for joining cables together. In the case of an extension cable, for example, where you have two or more cables that are mated, that are connected to get from point A to point B. Let's do a quick review, back Science 101. It might have been last year for you, or maybe many years ago in your science class where you learned a little bit about the basics of electricity and electronics. Really, when researchers are developing cables and connectors, or did develop them, they were looking for materials that they could use that the electrons would travel most freely, most smoothly down the cable, down the wire, from point A to point B. Remember that we want to select the material with the least amount of resistance. Electricity will always seek and travel the path of least resistance. So, for example, copper wire ends up being a very good conductor, and that's what we use in many wires, cables, and in some of the connectors. There are some additional materials as well, but copper ends up being one of the most popular materials. To contrast that, things like wood and rubber make very poor conductors. So electricity, the electrons do not like traveling down wood or rubber. If it has an alternate path, a different path, it's going to take that rather than go down the wood, rubber, or glass path. Now here's a spool of copper wire of what we call unshielded cable. You could string that from point A to point B, and the electrons would travel very quickly, very smoothly, with very little resistance. Now what we do, though, because we're using cables and connectors in environments where there might be things that would induce interference, where there might be other signals from other electronic devices, signals from, for example, mobile telephones, signals from microwave ovens, a variety of different devices would cause us to have interference and a less pure signal that might result in a fuzzy TV signal or crackly sounds in our audio, in our sound. So we do things called shielding the cable. And on the left is an example of a 4-conductor cable. You see there are 4 conductors wrapped in vinyl, white, black, red, and green. And then that cable dangling off to the right side is a ground cable. Now they are wrapped in a foil. See that kind of pink blue foil? And then that's coated with vinyl or plastic. And that prevents other signals from getting to the conductor cables that actually carry the signal. On the right is a different version. This is something you'd see in something called RG59, which is a high grade, a very high quality cable used in, for example, broadcast television and coaxial TV, running the cable TV signal to your home and around your home and into your home, etc. And so there's one. You can see the center core. That's one conductor cable. Around that, there's what they call the dielectric insulator. Usually, that's kind of, you can see the white color is like a plastic. And again, that is a very poor conductor. So the electricity stays in the center where it travels smoothly and doesn't like to get out. Wrapped around that is a metallic shield, and that can be a variety of different materials. And that kind of traps any electrical interference that's trying to get into the cable or that might get into the cable, and instead it travels down the line and goes to another part that's connected on the device that kind of grounds it out, that gets it out of there. And then it's wrapped in plastic as well to prevent any further contamination, if you will, or any interference. So there's examples of shielded cables. So if you're running long distances, it's often advantageous to use a very good shielded cable, as well as sometimes, depending on the distance, you may have to amplify the signal to boost it so that it can make that long distance destination. All this is being said to make sure there is an understanding that you have that cheap cables, really, really inexpensive connectors and cables, are probably not worth you spending the money. You spend a lot of money perhaps on your all the components, your cameras, your computers, your home entertainment system, etc. Don't save just a couple bucks and buy the cheapest brand of cable. Make sure you're buying a good, reliable cable that will last you for a long period of time. Let's quickly make a distinction between a jack and a plug. And this is important not because you're going to, go into the cable industry, but when you go to the electronics store and you ask for a connector, it is important that you ask for the correct end. It's a jack or it's a plug. So, what is a plug, Chet? I'm glad you asked. A plug is usually the part on the cable that has one pin or many pins. For example, on the left side, we see the yellow, white, and red. Those are called RCA phono connectors. We're going to get to those in both the audio and video section. And you can see there is a center prong or a center pin. There is a circular shield that also connects around the outside, but the center pin carries the primary signal. On the right, we have an HDMI connector used for most high-definition televisions, and you can see kind of inside of that long rectangular part is a bunch of little copper wires, so it's making many different contacts or connections. On the bottom center, we have a 1/8 inch mini plug. So that is a plug that oftentimes carries audio, sound for inexpensive microphones, and also many of us recognize that for headphones, earphones, earbuds, that kind of thing. On the other end, we have a jack. Now, the jack is considered the receptacle. It's commonly on the device itself. For example, in the top left corner, the component video connection. That's something you might see on a computer, on the output of a Blu-ray DVD player, that kind of thing. And that mates with the phono RCA cables. On the upper right side is an Ethernet port carrying the internet connection for many people on their computer or the modem or your router. Now, again, the jack is most commonly on a device, but it can be on the end of a cable as well. That's evidenced in the center bottom. That is the bottom of what we call an S-video cable. You can see there's actually 5 ports, 4 circular one and 1 rectangular one. So it can be on the end of a cable, especially if you're connecting 2 or more cables together between devices. So again, a plug has the prong. When you hear the word P for plug, think pin or prong. Okay. Oftentimes as well, the plug is considered the male gender when you're talking about cables and connectors, and jack is the female gender when you talk about cables and connectors. It is possible as well to have an adapter, okay, which changes the configuration so that 2 dissimilar configurations will be mated or connected together, and you can have barrels, which they can be both jack on a jack on each side, or they can be both plugs, for example. And we're going to get to that in the adapters section.